Alright, so this topic is degree of substitution, and it fundamentally kind of slots in the nomenclature region, which is why we're going to deal with it now. And it's really a way of figuring out how many things are bound to something else is kind of the best way of thinking about it. So the terms we're going to be using are primary, and that refers to, say, a carbon that has one other carbon bound to it. So this carbon right here has one other carbon bound to it. That would be a primary carbon. Or likewise, you have this chlorine bound to this carbon, and this carbon has one carbon bound to it, so this is a primary carbon, and that is a primary chloride. If you have a carbon that has two other carbons bound to it, then that is a secondary carbon, and so we would call that a secondary carbon and a secondary chloride. If you have three carbons bound to the same carbon, then that would be a tertiary carbon, and we would call this a tertiary bromide. And if you have four carbons bound to a single carbon, then that carbon becomes quaternary or quaternary. I've heard both pronunciations. So anyway, this is a tertiary bromide because this carbon, the carbon that the bromine is bound to three other carbons. So that is a tertiary bromide. This is a secondary bromide. This is a primary bromide. And again, it's because the carbon that the bromine is bound to two other carbons. The carbon that the bromine is bound to one other carbon, so that's a primary. Primary, secondary, tertiary. Looking at alcohols, you do it exactly the same way. This alcohol is bound to a carbon that's bound to one other carbon, so this is a primary alcohol. This alcohol is bound to a carbon that's bound to two other carbons. This is a secondary alcohol. This alcohol is bound to a carbon that's bound to three other carbons. This would be a tertiary alcohol, and that's how you do it. Primary, secondary, tertiary, quaternary, those are the terms you're going to need, and more or less what you're doing is looking at the carbon in question and deciding how many other carbons are bound to it. So rules are definitely made to be broken in the land of organic chemistry, so if we have a simple rule for degree of substitution, like this carbon is bound to one other carbon, so it should be primary, this carbon is bound to two other carbons, so this chloride should be secondary, this carbon is bound to three other carbons, so this chloride should be tertiary, then you'd like to be able to extend that to this series, and you'd say, well, okay, this carbon is bound to one other carbon, so that's clearly a primary amine, and here this carbon is a secondary carbon, but if I ask you whether this is a primary amine or a secondary amine, your instinct based on this would be to call it a secondary because this carbon, and so on. However, this is a primary amine. Why? Because this amine, this nitrogen, is bound to one other carbon. Now, this carbon, of course, is in fact a secondary carbon because it's bound to two other carbons. But here's the annoying extension of the degree of substitution idea. If we're talking about amines, they have the capacity to be bound to multiple carbons at the same time, up to 3 or even 4. So they can be referred to directly. How many carbons are bound to the amine, whereas a chloride is only ever going to make one bond no matter what. So if we talk about this being a primary, a secondary, or tertiary chloride, what we're referring to is the nearby carbon, not the chlorine itself, which after all is always bound to one thing. So a primary amine is an amine that's bound to one carbon no matter what else is on that. Therefore, this would be a secondary amine, and this would be a tertiary amine, and you in fact can get quaternary amines, which are always charged. So this quaternary amine is going to bear on it a positive charge, but this would in fact be a quaternary amine. It would be the cation of a salt. And by the same token, if we're dealing with amides, then this would be a primary amide. This because it has a carbon and a hydrogen, two carbons because of the carbonyl and that one. This would be a secondary amide. This would be a tertiary amide. And amides do not, in fact, end up quaternary for complicated reasons. So anyway, the relatively straightforward degree of substitution idea is the number of carbons bound to the carbon tells you the degree of substitution of the carbon. So this is a primary carbon, this is a secondary carbon, this is a tertiary. This is a primary carbon, this is a secondary carbon. However, the extension of the idea and chemists being sloppy with their language means that we refer to functional groups like this by saying this is a primary chloride, this is a secondary chloride, this is a tertiary chloride, and we do the same thing with alcohols. Whereas for amines, this is a primary amine, this also is a primary amine even though it contains a secondary carbon. A secondary amine instead is an amine that has two carbons bound to it, a tertiary amine is an amine that has three carbons bound to it, and a quaternary amine is one that has four carbons bound to it.